Hello friends, I am Dr. Sarika Panwar. We will continue our discussion of machine learning in today's lecture. Today we will discuss the least square method. Least square method, line of best fit, and how to calculate the line of best fit, and we will also discuss one example of least square method. What is least square method? It is a technique which is commonly used in regression analysis. Mathematical method to find the best fit line that represents the relationship between an independent and dependent variable in such a way that error is minimized. This line of best fit is based on the idea that a square of the errors obtained must be minimized to the most possible extent, and hence the name least square method is there. You will understand this least square method by using some examples. In this diagram now you can see there are two parameters wherein one parameter is dependent variable and other one is the independent variable. So sale of ice creams is the dependent variable which is dependent on the temperature which is there on the y-axis. As the temperature increases, the sale of ice cream will also increase. So we have to build a model, linear model for this data points. So definitely it is a continuous output. That's why we will use the regression method. So if we use this line as a regression line, linear regression line, then we have to, this is not the only line which can come out after the training. There can be more than one lines, there can be n number of lines which can come out of the training, and we have to select the best line which can fit to our data. That is done by using this least square method. Here this x1 and y1 are the variables which we have seen earlier in this diagram. Now see, whatever points lie on this particular model or this linear regression line, those points are exactly matching to the line. It means that there is a zero error. But if particular data point is not falling exactly on that line, means there is some error. So that error is calculated by finding the distance between the actual data point and the predicted value of that particular data point. So that difference is nothing but our error. So we find this error for each and every data point, and then we take the square and summation, and that will give you the sum of squared error. So here in this diagram you can observe that whatever data points are there which does not falling on that particular model or a linear line, then for that particular data point we find the distance between that actual value of the data point and the predicted value, and that is supposed t1. So similarly for each and every data point we find that distance, and then we take the square of that distance and then we add it. So that will give us the sum of the squared error. Okay, so this is how there are now in this case there are two lines which we can come up, and with both the lines we can find the sum of squared error, and whatever error is less, that line we can select as our final model. So how to calculate the line of best fit, that we will see. We know that it is a linear line, that is the linear regression model. That's why we will consider this equation y is equal to mx plus c. This is the equation of a straight line, linear line, and we know that what is c here. C is the y-intercept, x is the independent variable, and y is dependent variable, and m is the slope of the line. So this simple equation can represent a straight line along a two-dimensional data, that is x-axis and y-axis. So how to calculate the slope of this line m? With this simple equation we can find the slope of this line, that is n into summation of x y minus summation of x into summation of y divided by n into summation of x square minus summation of x whole square, where m is the slope of the line, n is total number of data points, x is independent variable and y is dependent variable. Now we can see how to find the y-intercept. We have seen that how to find this slope by using this simple equation. Now how to find the y-intercept. Y-intercept is nothing but see that if we can find with the help of dependent variable y, which is known to us, and slope and x. A slope we have recently calculated. So with these three known values y, m and x, we can get the y-intercept. So this is nothing but the y-intercept of this particular line. We can substitute these values in the final equation and we get the value of the dependent variable. We can understand this with this simple example where we can find the number of t-shirts sold based on the price of the t-shirt in dollar. So here what we can do, we can calculate the slope m with this formula. So once we get the slope by using n is nothing but the total number of data points, x and y are already known to us. So with this we can get the slope as 1.518 approximately. So in step 2 we can compute the y-intercept by using y, m and x. M we already know. For particular value of y and x we can get the y-intercept. Then we can substitute that value in this equation and we can get the value of y for the particular value of x. So our main aim is we need to get this c and value of m. Once we get the slope and y-intercept, we can put that slope and m for any particular value of x and we can get the value of y. In this case now we can observe that x, if we put $8, then for that $8 value we can get the value of y as a total 12.45. if we approximate it to the higher value, that is the 13 t-shirts, which this answer we can get, which is approximately same. So for 7 and 9 we have the values, and for 8 that is the unknown value. For that if we find, we can get the correct answer, that is y value is equal to 13 t-shirt. So if the t-shirt price is $8, then approximately 13 t-shirts can be sold. So what is the summary now? Least square method works by minimizing the sum of square of the errors to as small as possible, and that's why it has the name least square method. And the data must be free of outliers. That is the main requirement of this method, and line of best fit can be drawn multiple times until you get a line with minimum possible square of errors. And least square method works perfectly with the non-linear data also. Thank you, students.